Okay, so we're on page 20. The sample. What it is, it gathers information. I'm going to go fast, so you need to pay attention, stay up with this. Those of you that come in late, sorry. Only part of a population. So you're taking a sample of the existing population. So like this class is a sample of the population of the students at uni. Would be an example of what a sample is. A sample portion is using that sample the same proportion is x over n. Okay, x is the number of times the event occurs in n, in sample size n. Okay, so here's an example. I found out how to figure that. Press up. Ah, come on. I have something. Oh, I see. You know what? Try and turn on the top light on this. It's because I'm in a shadow. I'm so close to the thing. Pardis, can you turn the top light on, please? Top light. On. There you go. Okay. I don't know. It's not coming out very good. Okay, so in a sample of 450 teenagers, 48 have never dug a hole at the beach. Find the sample portion of those who have dug a hole at the beach. This seems have never dug a hole. So who has dug a hole would be, you would subtract it from there, and you would have 408 over 450, and it would be 201 over 225. Now, samples vary in how well they reflect the entire population. In a random sample, all members of the population are equally likely to be chosen. So when a part of population is overrepresented or underrepresented in the sample is biased. A random sample can help avoid bias in gathering. So if you look down here at these three things, viewers are invited to call the program and express their preferences. The people who decide to call in may over or underrepresent some views. For example, members of a group favoring a new dress code might encourage its members to call in. This type of sample is called and self-selected because they've called people to call in. Okay, they're trying to round up a posse to go do this. A reporter interviews people on the street near the local high school. This is called a convenience because, and you can read why, because he's just interviewing people around the local high school, which might be students, and they might have a different view than a parent on the dress code. During the program, 300 people are selected at random from a viewing area. Then each person is contacted. This has the least bias, so that would be called a random sample. If you look at both of these, and here you have 20 people per sample and 5 people per sample, and say which one would go with which graph down here, you would probably say that this one would go here because there is less variation, and the more people you have in a sample, the more accurate what you're testing for or what you're surveying for or what you're trying to find the probability of. So this has less variation, and since the graph on the right shows less variation, so it's more likely to based on 20 on a larger size, which is 20 people. Now, every time you take a survey or something, you're going to have a margin of error. And this is our statistical measure. All of these units relate to one another. Each one is not separate. They are totally related. These are all statistical measures to find out if your data and what you're saying are accurate, okay? And what your conclusions are. The more things that cluster towards the middle, you can make a more accurate conclusion. Okay, so this is what statisticians use. And the margin of error is when a random sample of size n, I want you to start taking the test at 10 till, is taken from a large population, the sample proportion has a margin of error on both sides of what you find. Okay. Formula. Margin of error equals positive negative 1 over the square root of n, and n is your sample space. So here is an example. A poll reports that 56% of the voters favor candidate B, with a margin of error of 3%. Estimate the number of voters in the poll. So here, if you're looking at this, the margin of error is 0.03. So that would be 0.03 equals positive negative 1 over n. I don't like how they solve that. So I'm going to cross multiply. So I would have 0.03 square root of n equals positive negative 1. Then I would divide by 0.03. And that's where they get this right here. They have the same thing here. This crosses out. So you have the square root of n equals positive negative 1, and I'll explain why it's positive negative. Boy, this is just coming in terrible. Okay, then you square both sides, and you would get, when you square this on a calculator, you will get 1,111. Okay? Okay. This is the same thing, what they're saying, as this, because remember, this is like taking 3 100ths. So it's really 100 over 3, which is 33.33. But if you put this in your calculator, put parentheses around it and square it. You don't have to do the plus minus, because when you square a plus minus, it's always positive. So that's how many voters. So they estimated about 1,100 voters. Now here, a survey of 2,580 students found that 9% are left-handed. Find the margin of error. So now we're trying, here the margin of error was given. Here we're going to try and find it. So if you're trying to find the margin of error, let's just say E, let's say ME, just so we don't get that confused with something else. It would be positive negative 1 over the square root of 2580. And when you figure that out, you will have 0.0197. So they're saying it's about a 2% margin of error. So if it's 9%, then it's going to go 2% to the left and 2% to the right, very similar to our standard deviation. This is also called a confidence interval. It's making you more confident if you're what your margin of error is. It's between 7% and 9%, rather than just saying a statement that 9% are left-handed. This gives you more confidence in your statement by saying that the number or the percentage of left-handers are between 7 to 11%. Okay? Any questions on that? This isn't in your book, but it's something that you should know for next year. Okay? Okay, now,